Today our topic is using algebraic properties. So our essential question or learning target is how can I use algebraic properties to form logical arguments? First off, on your properties reference sheet, you have different algebraic properties, and they're properties of equality, and we use these in order to solve equations. So our addition property of equality is if A equals B, then A plus C equals B plus C. That just says we can add C to both sides, and the equation won't change. Same with the subtraction property, we can subtract C from both sides, and the equation won't change. Multiplication property, we can multiply both sides by C, and the answer won't change. We can also divide both sides by C. And then the substitution property, if A equals B, then A can be substituted for B in any equation or expression. We also have the distributive property, which should be very familiar to you, which means we can multiply the numbers inside the parenthesis by the number outside the parenthesis and expand that expression. So we're going to use these properties to help us simplify expressions and solve equations. So we want to solve 2x plus 5 equals 20 minus 3x. Write a reason for each step. So our equation, we start here, and that's just write original equation, and our reason is always given for that first one. Alright, then we add 3x to both sides. We're used to seeing it like this, add 3x, but we're adding 3x to both sides. And the reason we can do that is our addition property of equality. And you can feel free to abbreviate in the way that I am abbreviating. The next step is combine like terms. We add the like terms together. We put our x's together. 2x plus 3x is 5x. And negative 3x plus 3x cancel each other out. That is just a simplification step. Next piece is to subtract 5 from both sides. We do minus 5, and the reason we can do that is our subtraction property of equality. And then the last piece, to get x all by itself, we divide both sides by 5. We get x equals 3, and the reason we can do that is our division property of equality. So solving equations should be very familiar to you. Now we're just adding that reason, adding our properties of equality to justify why we are allowed to make each step. Alright, our second example, we are solving the equation negative 4 times the quantity 11x plus 2 equals 80. And we want to write a reason for each step. So we have to do all the different pieces. So first off, we solve the equation. We're going to want to start by multiplying this negative 4x by the numbers inside the parenthesis. Our explanation would be multiply. That's what we did. And the reason we can do this is the distributive property. Next piece to solving this would be add 8 to both sides. And that would be our explanation. The reason we can do this is our addition property of equality. Last piece we would want to do is divide both sides by negative 44. So we can get x by itself. We have x equals negative 2. So that would be divide both sides by negative 44, and the reason we can do that is our division property of equality. Alright, if you flip over to the back of your property reference sheet, we have different properties. We have the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. The reflexive property just says that for any real number a equals a. So if you have something, it equals itself. It'd be like 7 equals 7. Also applies to segment lengths and angle measures. The symmetric property of equality says that for any real numbers a and b, if a equals b, then b equals a. So if we have 5 equals 5, well then 5 is going to equal 5. Also, if you think about it, if we have x equals 5, we could flip it around and say 5 equals x. That'd be another way of looking at that one. Same thing applies for segment length and angle measures. The transitive property says for any real numbers a, b, and c, if a equals b and b equals c, then a equals c. So if we said x equals 5, and then 5 equals y, we could say that x equals y because they're both equal to 5. Example 3, we have a logo. You are designing a logo to sell daffodils. Use the information given. Determine whether the measure of angle EBA, should be right there, is equal to the measure of DBC, which would be this angle right there. So we walk through our equation and our explanation. So if we look up here at our diagram, we have the measure of angle 1 is equal to the measure of angle 3. That's marked here. Those congruent angle measures means we have equal angle measures. So then the measure of angle EBA, right here, is equal to the sum of the measures of angles 2 and 3. They're being added together, those two. So add measures of adjacent angles. Then we say the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. We substitute the measure of angle 1 for the measure of angle 3 because we know that they are equal to each other, so we can make that substitution. Then we know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DBC because it's just shown in the diagram. DBC is comprised of angles 1 and angles 2. So therefore, since the measure of angle EBA equals the measure of angles 1 plus the measure of angle 2, and the measure of angle DBC also equals the measure of angle 1 plus the measure of angle 2, we can say that the two angles are equal. Now we have an example to try on our own. In the diagram, AB equals CD. This is shown with those congruent markings. If two segments are congruent, then their measures are equal. We want to show that AC, this piece right here, is equal to BD, that piece right there. So we start with our equation, AB equals CD, what we're given. It's marked in the diagram, and it was given to us in the explanation. Then we want to say that AC, this piece right here, is equal to the sum of AB and BC. So we're going to say that AC is equal to the sum of AB plus BC. Our explanation is add lengths of adjacent segments. And our reason behind this is our segment addition postulate, which we learned about in Unit 1. The next piece would be that we want to set up what BD is equal to, the segment length right here, and BD is equal to the sum of CD plus BC. We have the same explanation, so that's going to be the same for this one. And again, it's the segment addition postulate. So we can carry that down for both of those. Alright, so now if we go back up to this equation up here, and we add BC to both sides of it, our reason would be add BC to both sides. And the reason we can do that is our addition property of equality. And now if you look, AB plus BC is right here, so we can substitute AC for AB plus BC. And then CD plus BC is right here, and so we can substitute BD for CD plus BC. And we can just say substitute for our explanation. And the reason we can make these substitutions is our substitution property of equality. That's all the notes I have for today. Thank you for watching this video, and please subscribe to my YouTube channel.